My name is John Haddad. I'm a technical evangelist for DataStax. I'm going to be talking to you today about diagnosing problems in production. So I don't know how many of you were here for training yesterday. Everybody did some training. We got some data modeling talks. I don't know how many of you have put Cassandra into production yet. But you know, with any database, with any project, there's always a time when something goes wrong in production. What I want to do here is kind of outline some things that if we get done ahead of time, if we know about ahead of time, should help minimize the number of problems that we encounter. So the first thing that we're going to do is talk about preparation, right? This is stuff that we just should do, obviously, beforehand. You can't prepare afterwards. It doesn't work like that. The first thing is OpsCenter. You've probably seen this already. It's going to help you out with 90% of your problems. You can graph individual servers, JMX information, memory usage, compaction history. It basically is an operational tool designed to work exactly the way you need with Cassandra. It's going to be the first place you look when there's a problem. And the first thing to know is the community version's free, and there's a version that comes with DSE that has a couple more features. But the free version, really useful. It should be on every cluster. Aside from OpsCenter, if there's some other stuff that you want to take a look at, or you need to monitor the rest of your application, you're going to want to have tools like Monit set up, or Munin, things like CollectD to collect system metrics, tools like Nagios or Isinga, or you can use a hosted solution. Basically, you want to have a really good idea. If there's a problem with your cluster and one of your machines dies, let's say a disk dies, or an application is quitting or something, you should know pretty quickly without having to SSH into your servers and take a look, especially if you have more than a handful of them. It's kind of a nightmare. You definitely want to know right away which server is freaking out and what resource on it is constrained. So if it's a bad disk, you should know about it right away. And that shouldn't necessarily mean that you have to get up in the middle of the night. And with Cassandra, you shouldn't ever. But you definitely want to know what's wrong. So basically, if you're going to roll it yourself with open source, that's cool. If you're going to use some proprietary thing, also cool. Or you're going to use a hosted thing, do whatever you want. Just make sure you get something in place so that when something does go wrong, you are able to quickly diagnose which server has a problem. Now, aside from just looking at individual servers and processes and knowing when disks are bad, it's a really good idea to have application metrics built in. So I don't know how many of you have ever worked with a tool called StatsD, but it's really easy to integrate into your applications. So you can have timers, and you can have counters, and it also has gauges. And basically what you can do is profile very small sections of code in production, and you can kick this out to a tool like Graphite, and then you can effectively graph everything that's going on in your application. And what's really cool is Cassandra actually has a support for this as well through what's called the metrics plugin. And you can kick all of your Cassandra data and your application data into the same place, and you can get correlation. So you know that maybe you've got a dip in user signups, and there's a spike in compactions. And you can actually determine if things are related to each other and the root cause of some of your problems. Aside from the metrics integration, if you don't want to use that, there's another tool called JMX Trans that's really useful, and it can kick the JMX metrics out to wherever you want. So it's pretty cool. You can end up with some really flexible graphs. You can see the two I have on here. There's a nice dashboard with 9 graphs, or at the bottom there's a tool called Grafana. And basically it's just nice. It's that with the server metrics are really useful to quickly diagnose problems that you might hit. The third thing that I'm going to talk about is log aggregation. And this is something that I've actually had people fight me on in the past, and I don't really understand it. If you have a problem and you can take a look at logs and they tell you exactly what's going wrong, and they have meaningful data like user information, stack traces, just please do it. You will save yourself a huge amount of headache. Make sure that you don't have a ton of noise in your logs. Like if you look in your logs and you had 1 million errors in the last minute and nothing's actually broken, you're just totally wasting your time. Take the time, have good logs. It will help you out in the long run. I've solved dozens of problems that would take hours, and I've figured them out in seconds just from looking at the logs. Okay, so there's a couple things along the way that if you're running a Cassandra cluster, a couple things that you can just trip up on, and they're definitely outlined in the docs, but if you don't happen to read that one paragraph, or if you just don't care and you roll things into production, if you don't read as much as you should, I've done that pretty much every time. These are things that can hit you and they can impact you in a really negative way, and they're really confusing. The first thing that we're going to talk about is incorrect server times. So I don't know if anyone here has run into this issue, but it's kind of a nightmare if you don't realize it. And basically, if you have the wrong time on your servers, you can have a whole bunch of weird issues, especially if they're customer facing. But in the case of Cassandra, you can actually have some really unpredictable data either show up or disappear, or just weird conditions that can occur. So basically, whenever you do a write with Cassandra, everything comes with a timestamp. And if you have two servers and they have two wildly different times, like in my example over here, you can end up doing a write on, let's say, this first server, and it thinks it's ahead in the future, and then you can do a delete on the second server, and it thinks it's way in the past, and it turns out the delete won't actually take effect because the timestamp is behind the original one. It's a little bit of I honestly don't know how to diagram this to make it really obvious, because it's such a weird problem, but I can tell you that you can delete things and they won't actually be deleted. So you don't want to do that. It's weird. And the solution to this is really simple. It's just always make sure that you're running NTPD and your clocks are correct. So you want to do this on your application side and on your server side. A big thing that's kind of confusing for a lot of people is tombstones and the effect that they can actually have on your application performance. And a tombstone, as everyone probably already here knows, is it's a marker that data no longer exists. And it has a timestamp just like normal data. Kind of as I was showing you with the delete, delete comes with a tombstone comes with a timestamp. And they basically say, at this time, this data no longer exists. Now, you can run into a problem, which on the mailing list frequently might get called Tombstone Hell, that if you have too many tombstones, you can actually result in some massive performance failures. And the classic example of the thing that Cassandra is terrible at is a queue. So everyone seems to want to put a queue on top of Cassandra, and everybody runs into massive performance problems. It just does not work very well. So this example that I have up here on my slide is what happens if you have a really big partition and it's 100,000 rows. And at the front of that is 99,999 tombstones, and you only want to get one thing out of that. Well, Cassandra is going to have to read 100,000 rows or 100,000 tombstones just to give you one row in response. You're going to have a really crazy trace when you take a look at it, and everything's going to be really slow, and you're not going to understand why. So don't do that. Don't use it as a queue. Keep track of your tombstones, and you'll have a lot more fun. Another problem that is kind of a bummer is when you roll into production really quickly and you didn't take the time to research what a snitch does. And a snitch is really useful because, well, it's got a few uses. Primarily, for high availability, it lets us distribute our data in a fault-tolerant way. So if you've got a bunch of racks, let's say you're going to go in 3 racks or 4 racks, and you use a proper snitch, what's nice is it will make sure that your data is distributed to multiple racks around your cluster. What you don't want is to have all of your replicas exist in one rack and have that rack fail, and then you just can't get your data. So you're really not taking advantage of Cassandra's high availability in those cases. And the other thing that's really nice is it will allow for dynamic snitching, which will let your clients talk to the fastest replica that they have. So you're going to get a performance increase from using the right snitch, and you're also going to get high availability. So you definitely want to do that. And switching this after you've gone into production is really time consuming because you're going to have to run a repair, and if you have terabytes of data sitting in your cluster, all that data is going to be streaming all over the place. It's going to take a long time, and it's a huge pain, and you can save yourself that just by doing this up front. This issue is becoming less of a problem with newer versions of Cassandra, but I still recommend that you don't do what I'm about to describe, and the thing that I did. If you're running, let's say, an older version of Cassandra, like version 1.1, and you decide to upgrade to 1.2 or 2.0, what you don't want to do is try and bootstrap a new node of a different version. And the reason for this is the SS table format changes between versions and it breaks streaming. So I tried this and it basically just sat there for a few days and I was like, I don't know what to do with this cluster. And you end up having to like kill the node in a brutal way and then repairing, and it just turns into a total disaster. So if you want to upgrade your cluster, don't try and do it the clever way of putting new nodes in and have them be different versions. Just upgrade your nodes in place and you'll have a much better time than I did. Or if you actually have the right Snitch set up, which you should by now because I just talked about it, you can upgrade an entire rack at a time, as long as you're not using consistency level all, which nobody in here should ever be using unless you love downtime. So don't do that. This actually comes up a lot, and people run out of disk space. And they shouldn't, because they have alerts in place and they should know what to do, but you know, we run out of disk space. Okay, what do? We're going to add new nodes. And the problem here is when you add a new node, we're going to stream data to the new node from the old ones. And the thing is that the old ones won't actually delete the data. You have to run what's called a cleanup. And cleanup will just get rid of the old data and let you reclaim your disk space. So you could theoretically expand your cluster from 1 node to 1,000, but your original node is going to have the same amount of data on it. So you have to run the cleanup, or you're still going to have a full disk. And it sucks. You've probably heard this a bunch of times. I'm going to say it again. Do not use shared storage. This is a SAN. This is a NAS. This is EBS. It is not good. Single point of failure, even though everybody says, oh, my SAN has 300 drives and 26 power supplies and I don't know what else they have, but they have lots of things. And it sounds really cool, except when your SAN stops working, which it does, and your entire Cassandra cluster stops working. That's pretty terrible. So don't use a SAN or NAS or EBS. And the other thing to remember is even if it worked perfectly, you're still dealing with the fact that SANs are ridiculously expensive compared to just throwing solid state drives in your server. So it's going to be less expensive for you to use local storage. It's going to be more reliable, and it's going to be a lot faster. So those are all good times. All right, compaction trips a lot of people up. It's basically the process of merging SS tables. You've got a couple different options. The default one, size-tiered compaction, has been the one that's come with Cassandra for a long time. It's really good for write-heavy workloads, and it performs better on spinning disks than the other option that's been around for a little while called leveled compaction. Leveled compaction will give you a performance increase in read-heavy workloads and update-heavy workloads. So if you've got one of those, and those are actually the workloads that I've worked with primarily, leveled compaction can be a huge help because it's going to minimize the number of SS tables that a particular partition falls in. So read-heavy workloads, anyone here? Good times? Not a single read-heavy workload? This guy with his camera probably? All right, whatever. You can take a look at how much compaction is going on, and you can throttle it via node tool, and that's useful. You can stop it if you want. You shouldn't. So like I said, leveled compaction, really good for solid-state drives and read-heavy workloads, and you're going to want to stick to size-tiered if you're on spinning disks. There's another one that just came out, date-tiered compaction, really good if you've got time series data with TTLs, because it'll drop an entire SS table at a time. But it's pretty new, so kind of test it out a little bit. I haven't used it yet in production, so I don't know. So let's suppose you've got all this cool monitoring in place. Everyone feels good. We've got application metrics, whatever, but we still hit a problem. Well, now this is kind of when we, take off the gloves, we hop on a server, and we got to bust out our command line kung fu. So the first tool A lot of people are probably familiar with this. This is pretty straightforward. It's just a nicer version of top. Everybody should have HTOP. Everyone should be familiar with this. Pretty straightforward. I won't get into it, but it's just nice for process management. It gives you a good overview of what's going on. The big thing that, the resource that really is the most limiting when you're dealing with Cassandra is usually your disk. So iostat has been a really useful tool. There's a awesome combination of flags, DMX, that I like to use, not because he's an incredible rapper, but because those flags are actually useful. And you can basically get a quick overview as to what's going on each of your disks. You can see how much read and write is happening at any given moment, what your queue size is. So if you've got it says average request queue size in there. If that number is really high, it means that there's a ton of requests that are queued up on your disk. That's bad. You don't want that. Await, you're looking at how long a request has to stay in the queue before it gets serviced. So if those numbers are high, it's bad. Percent utilization is unreliable. Kind of ignore it. I wouldn't bother with that. Another tool that's really nice is VMstat. Basically, it tells you about virtual memory, answers your question, am I swapping? Generally, I personally recommend disabling swap. If you're hitting swap, your performance is going to be so bad that your node might as well be down. You might as well fail and just restart it and figure out, like, do I add new nodes? Do I put more memory in the existing ones? Generally, you want to just bootstrap new ones, and it's awesome. But if for some reason you've got swap on there, you want to take a look and see if swap's happening. DStat is kind of a combination of the tools that I've already talked about. So if you hit an issue, this is actually my first go-to. I'll check HTOP to see if anything shows up there, but DStat gives you a nice overview of your resources. So you can take a look at disk, CPU, memory, and there's a whole bunch of flags in here. You can literally get anything you can think of. So I recommend everybody put DStat on their machines. I know with Ubuntu it doesn't come on there by default, but install it, just make it part of your regular thing. And whenever you have an issue, just check DStat right away because it answers a lot of questions. If you want to get a little bit more intense, and this is really helpful if you have an application server that's freaking out, I recommend learning a little bit about strace. Strace can show you all of the system calls that are happening on a particular application at a moment in time. So you can filter it out to network or disk or whatever. And what it'll do is it'll just show you the individual calls that are happening. So what I did here was I ran strace on just the touch command, touching a random file. And you can see all the system calls that are happening along the way. And I've used this to figure out some really gnarly issues. I'm like, what is this thing even doing? And then I found out I had a process that was trying to connect to some remote IP address. And yeah, it just was timing out. And it was really easy to figure out what was going on with strace. Kind of a nightmare to go through and put in debugging statements all the way through the code. So this is a good time. Kind of on the same idea, if you want to get a really good idea of exactly what's happening on a particular port on a machine, you can run tcpdump, and this just lets you watch network traffic. And you can get a really great idea of all the queries that are being executed on a machine. I've used this to check out statsd and make sure that data was actually coming into it. Or you can sit and watch client requests that are coming in. You can just spy on everything, and it's really convenient. So I've solved a ton of problems with this tool. So Cassandra itself comes with something called Node Tool, which everybody, I hope, has heard about, since I think I mentioned it already, and you're all paying attention. And Node Tool has something called tpstats. And tpstats is pretty cool because it can give you an idea of the different things that are going on within Cassandra and what's been blocked. And there's a ton of things in here, but a big cause of a lot of problems is you can just look right to memtable flush writer. If you've got blocked memtable flush writers, then you've probably got really slow disks. And the other thing that this can result in is a lot of garbage collection issues. So if you've got a ton of memtables that are just sitting in memory, they're going to be promoted, and they shouldn't be. They should just be flushed. Or they're just sitting in memory, taking up your old gen, and you don't want that. So lots of issues there. Make sure that nothing is blocked. Blocked is bad. And the other thing you want to take a look at is dropped mutations. So if you've got dropped mutations, then there's a good chance that you have inconsistency in your cluster. And if you're doing queries at consistency 1, then you're going to get back some old data. So you're going to want to run a repair if you've got dropped mutations. Another really useful tool is in Node Tools, Histograms. So this is actually from Cassandra 2.0. There's a new version of Histograms that's actually nicer in 2.1. And the first one is proxy histograms. And that basically gives you an idea for your cluster at any given moment in time how long queries are taking that are being performed on that single node. And this is actually going to take into account all the network time. It's the full time to execute a query. So if other nodes are misbehaving, then proxy histograms will actually have some outliers where the numbers are really high. So it's not useful if you want to determine which node is having a problem, but it's useful to understand, like, are there problems at all? CF histograms is a much more useful tool. Once you've kind of looked at proxy histograms, you figure out, like, okay, like maybe this node is having a problem. You can use CF histograms to identify individual tables on individual nodes, and you can basically get a really good idea of which tables are slow. And that's really the thing that you want to figure out. And once you figure out what tables are slow, you can ask yourself, which queries am I performing against that table? And hopefully, if you set up your metrics to begin with, you should actually already be able to look at your logs, which are being aggregated, and you should be able to look at your dashboards that you have set up, and that should help you identify the queries that are broken. So once those queries that are broken are identified, you should be able to use query tracing. And effectively what we have here is I built a table called Tombstone Mayhem, filled it up with tombstones, and this is basically the queue that I was talking about. And you can see from the trace, there's just a bunch of steps along the way. And down at the bottom, you've got red 0 live and 100,000 tombstones. And you can see how that number just jumps way up. This was actually performed on a solid state drive, and everything was compacted, and it's still super slow. You don't, this reiterates my tombstone point. But you can use query tracing to figure out, did someone put a queue in production, and why did they do it? So the last thing that I'm going to go over is the JVM and garbage collection. So this is kind of a pain for a lot of people. It's confusing. Even people that have been Java programmers for like 10 years are like, I have no idea what's really going on in the JVM because there's about 1 trillion flags and like whatever. It's really not that crazy, so I'm going to attempt to break it down in just a few minutes. Everybody should walk out of here with a good, at least fundamental idea of what's going on in the JVM, and we could start to reason about how it impacts the performance of our cluster. So JVM, nice, automatic garbage collection, basically means that we don't have to manage memory anymore. I know some people love doing that. They love just allocating memory and freeing it. I personally don't care. It's just annoying. I never do it right. Everything's broken. The one that that Cassandra defaults to is par_new for new gen and CMS. So you basically have these two sections. There's the new gen, which is composed of Eden and 2 survivor spaces, and then an old gen. Now the new gen basically is the place where any new object is allocated. So if I create a new cell in Cassandra, which is basically the smallest container of data that I can have, it's going to be created in the new gen. And if that sticks around long enough and we hit a minor GC, which is when Eden fills up, the objects that are still active are going to be promoted into survivor. Okay, so you've got new stuff in Eden, promoted into survivor, and if it stays around in survivor long enough, it gets promoted into the old gen. And whenever you hit a minor GC, it's a stop the world operation. So literally everything stops, and it's going to go through, look at every object in your new gen, and determine, does this thing need to be promoted? If it doesn't, then it can be thrown away. That's super fast. So you could have like a 10 gig new gen, and if none of those objects need to be promoted, your stop the world time is going to be really fast. But if all of them need to be promoted, then you have to copy 10 gigs of data out. That's super slow. You can start to kind of reason about your workload, and you can start to think about how does this impact garbage collection. I'll have a couple examples in just a minute. So once we're in the old gen, we've got a bunch of stuff around here, and it's this giant slab of memory, and there's this concurrent operation that's happening all the time in the background, and it's taking a look, and it's marking objects, and the garbage collection is happening continuously. And there's 2 short stop the world pauses in there, but they're generally not a big deal, and they shouldn't impact your performance. The thing that does impact performance is when your old gen gets filled up. And when your old gen gets filled up, it's basically going to stop everything, collect a bunch of stuff, and reorganize things, and that's super slow. When everything gets filled up, then you run into a full GC, and that can take a really long time. I've heard of full GCs taking over a minute. You don't want to do that. Really bad time. So, yeah. So we run into 2 problems, and they come about from different workloads. The traditional advice on that you read in either the Cassandra mailing list, IRC, or even the config file itself has always said, don't put your new gen above 800 megs. And that's based on the idea that we have a write-heavy workload. And with a write-heavy workload, we're not really creating a lot of short-lived objects. And that's okay. So you want to keep your new gen to be small because there's a lot of stuff that's going to stick around, and it's going to be promoted, and you don't want to do that 10 gigs of copying like I just talked about. Sucks. So you're going to have a lot of minor GCs, and it's, like I said, it's just slow. I'm sorry. The problem with early promotion is if you have short-lived objects that are being promoted prematurely into the old gen. And that's when you have a lot of minor GCs. And what I've seen this on is read-heavy workloads on solid-state drives. So in this case, you actually want to increase the size of your new gen. And you can see here we've got early promotion into there. The other problem that we can have is long minor GCs. And as I mentioned, this is the one where your new gen is too big, and there's a lot of objects, and they all need to be promoted. So to figure out if you're having promotion issues, you want to use a really convenient tool called JStat. There's some other tools called JVM, and it's really useful, but I personally prefer the command line tools because it's just faster to get up and running, and JVM is kind of a pain to use on a remote server. So JStat has an option called GC util, and you just give it a PID and an interval and the number of times that you want it to print out, and it will show you the percentage that's being used in your survivor spaces, your Eden, and your old. And you can see if data is bouncing, like if a ton of data is bouncing back and forth between survivor or a lot of data, or if your old gen is filling up really quickly, then you definitely want to do some GC tuning. And you can see there's a couple flags in here. There's young gen count, and there's young gen count time, and then there's old gen, or there's full gen count time. And you can see how much time was actually spent at each interval doing garbage collection. So really useful tool, and it can help you kind of determine if the tweaks that you're making are having the effect that you're looking for. So basically, the thing that you want to look out for, long multi-second pauses, right? If you've got stop the world pauses happening all the time, your cluster performance is going to be terrible. And the thing that's going to be really confusing about it is you might have, like if you're running in Amazon, you're probably running Cassandra on one of the nodes that have 16 cores, and your CPU won't actually be very high. Your memory usage won't be very high, and your disk won't be high. So it's going to be really confusing to figure out which one of your resources you're restricted on. And yeah, you definitely want to check the GC side of things and see how much time you're spending in there. And like I said, if you've got long multi-second pauses, that's happening because of full GCs, or you could have long minor GCs, and that's because you're promoting too many objects. And the question that kind of comes up here is, how much does this matter? Like, is this having a true impact, or is this one of those things that's like, we're optimizing for a 5% increase in performance? So this graph that I'm going to show you, we took after doing GC tuning at my last company. We actually got about a 10-fold increase in performance. So we had a 20-node cluster, and its performance, or sorry, I think this was a 12-node cluster, and its performance was pretty terrible, and we decided to do some GC tuning. We bumped up, and it was a read-heavy workload, and we bumped up our new gen size, and we bumped up our old gen size, and it performed a lot better. So this is what you can do. Everyone was really happy with this because it was way more awesome. So yeah, I recommend playing around with this and learning. So what do you do when you get the call, stuff's broken, please fix it? We're going to narrow down the problem. You want to ask yourself, is the problem even Cassandra? You should be able to, with all the metrics that we have put in place, with all the logging, we should be able to know which part of our system is actually broken, which one's throwing the errors, where are they coming from. If it is Cassandra, our node's going up and down. OpsCenter can actually answer a lot of these questions, but if it can't, you should have all this other logging in place and metrics and aggregations. Do you have slow queries? Is it the JVM? Use your query tracing. Again, use your logging. Figure out if you're misusing Cassandra, trying to use it as a queue, if you have compactions. Get to the bottom of this, figure out what resource you're constrained on, and make sure that doesn't happen again, and also set up the logging so that you know if this is an issue in the future. So I think now we have a few minutes for Q&A. Yes? 3 minutes? All right, Q&A. Yes?
You talked about Tombstone Hell.
Yeah.
Can we have heavy workloads? I'm talking about Tombstones. Can we have delete heavy workloads on partitions? Can we delete a full partition and then not have issues with Tombstones?
It depends. So if you do the delete and then you're trying to read it again, then you will have a problem. So I would not recommend creating a partition with, like, let's say 100,000 rows and then deleting it and then trying to select from it. You will have some massive performance problems.
Okay.
Say a bit more about ABS and why it's bad, because provisioned IOPS are fast and pretty cheap.
So the big problem with EBS has always, for me, been reliability. There has been, every year that I've managed operations for a company, I've had to deal with total EBS failure across an entire availability zone or multiple zones. Shared storage is never going to be more reliable than putting storage on an individual machine. And remember, whenever you do a request over EBS, it's still happening over the network. So it's always going to be faster to use local storage, and it's always going to be more reliable. I'm done? I'm getting kicked out. You can find me and meet the experts after this.